So when we talk about this chapter, superposition, we are actually basically talking about interaction between the waves. So when waves interact with each other, we call it interference. So interference is not necessarily a bad thing for waves, because you can have either constructive interference or destructive interference. Because usually we associate interference with something bad, but it doesn't mean it's something bad. So as long as the two waves overlap and there's interaction, we call it interference. So under this chapter, we're going to talk about a few phenomena. We're going to talk about two-source interference, right? That means interference between two sources, which are coming out in the same direction. And then we will also have stationary waves, which are interference between two waves traveling in the opposite directions. And then we will have diffraction grating, which is interference between hundreds or thousands of waves coming out in the same direction. So this will be the phenomena that we're going to learn. But let's talk about what is the principle behind the interaction of waves. It means when waves interfere or interact, what must it follow? It follows what we call as the principle of superposition, which is also called the definition of interference. That means if they ask you to define interference or they ask you to define the principle of superposition, you write the same thing. So which says that at a point where two or more waves meet, the instantaneous displacement is the vector sum of the individual displacements due to each wave at that point. It means that whenever you have the two or more waves meeting, what will happen is they will combine together to give you a resultant wave, and the resultant wave will have a displacement that you will obtain by adding both displacements of the both waves vectorially. Example, if you look at this question, this example, so there are actually two waves here. One is this wave. Can you see this one, the small wave? Another one is this big wave here. So if let's say the two waves meet at a point, so what will happen is they will keep interfering. That means as time goes on, we will find a resultant displacement. That means these two waves will disappear, and what you will see is a resultant wave. So you won't see the individual waves anymore. You only see the resultant wave. And how will the resultant wave look like? So at t is 0, the displacement due to both waves is 0. So then this resultant wave is 0. But at this time here, let's say we take this peak here. So you add up, let's say got 1, 2, 3, 4, 5 boxes for this wave at this point. Then here got 6.5. So 5 plus 6.5 give you 11.5, for example. So you count 11.5 boxes. So that is your wave, your resultant wave. So at this time 0, 0. So your not 0, 0, 0, and how many you count? 1, 2, 3, 4, 5, 6, 7, 8, 9. So for example, then you just add like that. So every time you add both this plus this, this plus this, this plus this, this plus this, then you get your resultant wave like this. Understand? So that's called principle of superposition. Now for examples that we are usually seen before is like for constructive interference here and destructive interference here. For constructive interference, you'll notice that because at the same time they have the same displacement, you see not 0, 0, maximum, maximum, 0, 0, minimum, minimum. So when you add up together, they become double. But if they are opposite, 0, 0, same, but maximum and minimum meet, then you add up both together, you get 0. Then 0, 0 gets 0, minimum meet maximum, you get back 0 as well. So that is also principle of superposition. So what are the three conditions in order for the waves to meet? But just to highlight something as well. So when they meet, right, they will form a resultant wave. But if let's say they cross each other's path, for example, one wave travels this way, one wave travels this way. So when they meet at this point, then you will use the principle of superposition. But after that, the wave will continue along the way, right? So it will behave as usual. That means separate already. So it's not like once they join, they will forever get married and move together. No, they will just meet at that point, undergo the principle of superposition. Then after that, they'll move by itself. So separate wave. So they will not combine forever. Only at that point where they meet. So what are the conditions in order for the waves to interfere? So if they ask you what are the three conditions for the waves to interfere, number one, they must obviously meet at the point. If they don't meet, they cannot interfere. Right or not? Number two, they must be same type of wave. So you can only get interference between like sound and sound, light and light. Like that. Sound and light don't interfere. And then they must be polarized along the same plane. So what does it mean by polarization now? Although it's been removed from the AS syllabus, but we just know a little bit of it is enough. That means they're oscillating in the same direction. Now, if they don't oscillate in the same direction, if they're oscillating at angles, then what we have to do is resolve vertically and horizontally. So the vertical must add with vertical, horizontal must add with horizontal. But if let's say one of the wave is vertical, one of the wave is horizontal, can we add them to get the magnitudes? Cannot, because vectors say if you have two perpendicular vectors, you won't affect each other's magnitude. That's why it will not interfere. That's why it must be polarized along the same plane. Okay, but these are the three conditions for them to meet. Whether or not you get a clear pattern is a different story. That comes under conditions for steady interference pattern. So whether it forms a pattern is not important. It's whether they will interact or not. That's it. Okay. Okay, so now let's talk a little bit about what is coherent. Coherent. Now, what does it mean by coherent sources or coherent waves? Now, for waves to interfere, they need not be coherent. But if you want to see a steady interference pattern or a clear pattern, then they need to be coherent. We'll come to that in the next part. But what is coherent first? Let's explain. Coherent means like this. Let's say you got the first wave, which is here, and your second wave, which is like this. Okay. Now, coherent simply means having constant phase difference. Alright, now, can you see that in the beginning they started together? They reached their maximum together, they reached the middle together, they reached the minimum together. They are coherent. They do not have to have the same amplitude. As long as they're moving together, that's called coherent. Another example, for example, okay, I'll give you another example. Now, what about this one? Are they coherent or not?
Yes.
Also, because you will notice they have a constant phase difference of 180 degrees. Can you see that? So they are also coherent. What about another situation? First wave, second wave. Are they coherent?
No.
They are. You know why? Because there's a constant phase difference here, and here, and here, and here, and here. You understand? So there's what we call as coherent as well. So constant phase difference. That's all. It doesn't have to be in phase, out of phase, specifically certain value. It can be any value as long as it's constant. So you'll notice that in these three cases, when they're coherent, do you realize that automatically you will get the same frequency, amplitude, frequency, wavelength, and speed. Or maybe I use V. But what is not compulsory is amplitude. Amplitude no need to be the same one. As long as the same frequency, wavelength, and speed. That means actually it's due to constant phase difference. But when they have constant phase difference, it automatically implies that they have same frequency, wavelength, and speed. So when will they be not coherent? Okay, when they're not coherent, what you will notice is one of the wave, let's say like this. The second wave will definitely have a different frequency. I use a different color, like this. Like this. So can you see that the frequency is not the same, right? And because frequency is not the same, do they have the constant phase difference?
No.
No. So do you understand what is not coherent? Okay?